Hello, everyone, and welcome to the session. When moving to electrification, it's very hard to know where to start, especially if you're not familiar with the process or the products. My colleague, Benny Forsman, the North American Business Development Director for the ZAPI Group, has over 20 years of experience in the electrification space. Today, he's going to take you on a little adventure and provide a bit of a Kickstarter roadmap to any curious about where to start in the electrification process. Please add any questions to the Q&A tab to your top right, and remember that this session's recordings will be available after the session. With that, please take it away, Benny.
All right. Good morning, good afternoon, good evening, depending on where you are in the world. I intended for this to be a fairly high-level overview of electrification for mobile machinery. There will be a few times when I can't avoid to put my sales hat on. You may roll your eyes or find it useful, but in general, this will be a fairly high-level overview. So from the objective here, equip OEM development teams with a bit of more knowledge about how to overcome obstacles in the electrification process. We'll see how well I manage to meet that objective. I have to give a little background of where we are coming from when we talk electrification. So within the ZAPI Group, these are various brands and product areas that we supply products to. Definitely in terms of size of the business, the battery chargers, electric motors, and electric motor controllers are the bulk of what we do and have done for 50 years. So that's the background that we're coming from. When we look at the EV adoption, what we call industrial vehicles, which in this case is primarily forklifts, you will find that you are way ahead in the mainstream adoption. The majority of forklifts today are already electric. And that's kind of the backbone of our business. We look at the automotive on-highway space, and we find that the transition to electric vehicles is definitely gaining momentum. It's not at the full adoption levels, but it's definitely picking up speed. People may argue that it's not picking up speed quite as fast as others have expected it to do, but nevertheless, we are there. And in the off-highway area, we are really in an early adoption phase. Manufacturers are developing machines, they are being put out there, customers are starting to build experience with them, but it's early. So and then another discussion around that is looking at it from a time perspective. This slide was put together, I would argue that in the light electric vehicle space, it definitely started a lot earlier than this, because you will have found forklift, golf carts, work platforms being way ahead in the electrification space also a lot earlier than this. But we see other areas, the turf industry, small excavators, things in this area is really starting to electrify in this area. The mid-range size, we see a lot of development in the market that are looking for product launches in the nearest couple of years here. So I think we'll see a lot more development or a lot more product launches in this space coming in the near couple of years. And in the large equipment space, for sure, we see electric trucks and buses starting to be on the road, but as it seems, the more widespread adoption is still a few years out. So those seem to be more in the 2027 to 2030 timeframe. I have one little case study in the material handling space because I think that there are learnings to be done. So what happened there when this market truly electrified? And I'm starting with a comment. Someone who was saying, we overestimate the impact of technology in the short term and underestimate the effect in the long run. So while we always tend to think that the world is changing in the nearest couple of years, maybe it doesn't. Maybe it takes quite some time to get to a more widespread adoption. But what has happened over a longer run in this space? So when we look at the counterbalance forklifts, the typical sit-down trucks, those exist by all brands in both electric and IC powered versions. And this is what has happened over a 10-year time period. I was looking at 2013. What was the share of electrics? Well, in Europe, it was 46%, in Americas, 27%, and in Asia, only 18%. And we find that over the 10-year time period, there was a significant shift, especially in Europe, where now 2/3 of the forklifts are electric. In the Americas, there was a small change, 6%, but it was still sort of in the more earlier adoption area. But one interesting thing was then to compare 23 to 24, and even when we look at Americas, suddenly we find that what took 10 years of conversion in Americas to grow 6% of share suddenly happened in 1 year. So from 33 to 39% in a single year. One way of looking at this is also that I think a lot of people kind of miss this because since 2013, the global market has doubled in terms of number of forklifts. So people are still looking at the IC engine forklifts will say, well, but the numbers have grown in this time period. It was growing by 14%. But then you're missing that the electric counterbalance forklift sales was growing 140% in the same time period. So why has there been these conversion? Well, operating costs are definitely a key driver there. Maintenance and uptime. I know I had a large fleet operator that was commenting on how he would have wanted every one of their forklifts to be electric because for the IC engine fleet, they have to have additional forklifts just to make up for the ones that are out of commission at any given time. But for the electrics, we only replace the seat covers every couple of years. So maybe an exaggeration, but at least his perspective. I think we also see a lot about productivity and ease of use, that it's quicker to get the new operators up to speed. And I know in some of these markets, there is more than 100% annual employee turnover. So ease of use and making it easy for new people to learn to use the equipment helps. There's some advantages in operator comfort. I had a bullet here about the California Air Resources Board and the ban on IC forklifts that is coming in 2026. I had to put the question mark in here because with the new administration, it seems like California, this is still a law, but they are expecting that they will not be able to police it in a sense. There will be no effects of breaking that law. And what are the hurdles? Well, one clear hurdle is the higher upfront costs, and one is around charging infrastructure. Is there enough electric power to have chargers enough to charge the fleet of vehicles during the time when they are available for charging? So moving into then the next step, the do's and don'ts of electrification, and bear with me that these are kind of personal opinions from my experiences from the years within this industry. But a lot of it may sound extremely like a given, point one, have a plan. And I will go through all of these items in separate slides here. So on the have a plan, the plan should be beyond, well, make the machine electric. And these are some examples of questions that you really should have good answers to before you engage in or before you start the electrification efforts. Who is going to buy it and how are they going to use it? What specific advantages is it that you want this machine to have? So these are all examples of questions that you really would want to have an answer for. And don't electrify for the sake of electrification. So I have actually heard this several times. We don't really know, but management has decided that we are to do this. That's typically not a good recipe for developing a good electric machine. Engage suppliers before finalizing specifications. So when you do engage suppliers early and often, you can get a good understanding for scalability and longevity. If I'm starting down this path, do I have a good runway for the development of the coming 10 years? And of course, investigate what is available on the market. Sometimes you see design work that is being done in a silo. And the first one, I'm kind of joking. We have hired an expert with a PhD who is writing the specification for us. It's surprisingly common that we have to have difficult discussions with customers about the fact that this is a specification that you have written that is really not going to give you a product solution with components that are available or manufacturable. And I'm saying that the most common mistake is probably to have unrealistic expectations for performance versus space claim. Because for the electric machine, you do need to have space for a battery that is large enough for what you want the machine to do. you do need to have motors that are large enough for the torque that you need for the machine. One topic may be around system optimization versus component optimization. And what I mean by that discussion is you want to start out optimizing for both battery and motor and controller and charger for the whole system. And you need to size the battery, the DC current capacity for the actual real use. And people in the battery industry might disagree with me, but don't trust the data sheet info. You want to know what the battery can actually do, and then optimize the motor and controller together. Sizing for what you can actually pull from the battery. Don't forget the need for proper motor tuning. That is a common issue that we see. You buy a motor from one supplier, you buy a controller from a different supplier, you put it in the vehicle, and you realize that you hadn't tuned the two components to work well together. And don't design around one component. We found this great motor. Well, it just didn't work well in the system because, for example, in permanent magnet motor situations, maybe you find out that you have an overvoltage risk at high speed that the controllers aren't really capable of handling. So it seems natural, but it's kind of a difficult thing to do, to combine all of these things early on. One specific topic about charging, you will need to choose whether to do onboard charging or offboard charging. But my point is, I think you should often consider both. Size the charger based on available connections at the time, at the kind of sites where this machine is to be charged. So, of course, voltage, max current. Do you have access to three-phase or just single-phase? And what is the battery max charge rate? And what is the available charging times that this vehicle will be available for the charging? So look into off-board chargers for faster charging times when you can bring the vehicle to the charger, and onboard chargers for opportunity charging, where you can plug in wherever the vehicle happens to be at the time. And from my experience, then, don't select a charger that doesn't actually work. There are plenty of chargers in the market space, and not all of them are good for the type of environment that you intend to run this machine in. And even if it's easy to view the charger as kind of an less important add-on to my really nice machine, but whenever there is a problem with the charger, trust me, the end user is going to be unhappy anyway, because he has a machine that wasn't properly charged and won't do the work that needs to be done. Weighing cost versus performance. Well, obviously consider the trade-offs. Try to understand the drivers of the buying decisions in your market. And don't assume that performance outweigh costs. For sure, we all want to sell high-end products, high-end machines at good margins. But is that really what your market wants? And I would say, from my perspective, I would say too expensive is heard more often, or at least just as often as not good enough. And that in the end, no one wins if the machine doesn't sell. This is where I put a little bit of my sales hat on, so bear with me on that. But do select long-term partners. When you focus on an established partner as your supplier, do the supplier have the resources and experience to help you in the right way? And I've seen a lot of cases where, from an OEM perspective, are the startups and venture capital funded suppliers a match made in heaven? Will the supplier even exist in 10 years' time? And will the generation of products that you selected exist in 10 years' time? What does that runway look like, and the availability of support and spare parts, not just now, not just during the time that this machine will be manufactured, but also for the long-term aftermarket and spare parts situation. So, of course, from our perspective, we want for you to don't treat the components as a commodity. If this is your first electrification project, do find a partner that you can consult with and work together with. And of course, we have good competitors in the market space that also can do this for you. So this is my little bragging alert. I'm saying, when we look at ZAPI Group North America, the top 4 customers that we have been with us for 20, 25, and 40 years. So that's been a good partnership for both sides. I was brave enough to try to take a couple of examples of the good and the not so great. And please note that the pictures are not necessarily showing the actual OE machines. These are examples. One example that could have been so much better, a customer that was developing what definitely seems to be the world's best electric brush mower, but it's just not selling much, even with a 33% price reduction that has been implemented. It's kind of sad, but I guess it's just one of these cases where it's a bit overkill for. A good example, we have a customer that I think did a fantastic job optimizing the design of their hydraulic system in a boom lift to absolutely use every inch of the available battery power in this machine. They really looked at how much current can I get from the battery, and how can I optimize the use of that current to get maximum performance in the vehicle. And we could jointly design a motor and controller solution that was really optimizing whatever was available from the battery. This is one of my personal favorite applications, just because I think it was such a great fit. It's a hybrid system for a wood chipper, and it was designed to allow using a much smaller diesel engine, going down from 60 horsepower-ish to under the 25 horsepower limit, and instead use an electric machine to create a hybrid system. and the performance of the machine ends up outperforming anything out there, because the instant torque of the electric machine prevents the engine from bogging down when you start feeding the chipper. In the not so great space, we have had one example where the battery is limiting the performance in a pushback tractor. We struggled understanding why it wasn't really giving the desired vehicle performance, and it turned out that, well, we're not able to draw more than a certain amount of current from the battery. So at the end, a smaller motor and controller had probably given the same performance to the vehicle. One current example that is, in my book, very good, a terminal tractor manufacturer that really settled on using high volume on highway components from the truck industry, and thereby be able to piggyback on the cost and quality of components, creating a more specialized machine. The final one, this one I'm probably allowed to use the name. I really like what the small Swedish manufacturer Hudig did for a very specialized off-highway tractor, where they are using both onboard and offboard chargers in that application to allow fully grid connected operation. So you can run this machine with it connected through the offboard charger in a fully electric mode, and when otherwise you can run it in a hybrid vehicle mode. So repeating my key takeaways. I mean, the first one, really think it through. The more time you spend on planning and understanding the market needs and development of the specification, it will definitely impact your success rate. Consider the whole system. No components work in a silo. So when you focus on the optimization of the full system rather than picking one specific component at a time, you typically end up with a more balanced and better functioning system. Leverage mature ecosystems. Definitely industries that are in this early adoption space, you can still gain advantages from using solutions that have been made in established ecosystems. Material handling on highway are examples. And choose the right partner. Of course, we want for you that partner would be us, but for sure there are several competent and good suppliers in this electric space. But I would still argue more often than not, choosing the right supplier partner may be more important than choosing a specific component. So you are welcome. Come talk to us. Look forward to helping you in this electrification space.
All right. Thank you very much, Benny. It was a great presentation. Could you maybe take a bit of time to explain, what you see as some of the most crucial hurdles for the shift from IC to electric vehicles?
Well, I think I touched on it in the presentation. I think that the two things that may be more important than anything else. One is really understanding what are your customers willing to pay, because we do see a lot of great designs, great machines that perform perfectly, but they get priced to a point where customers aren't really willing to pay that price for the machines. And then the other main hurdle might be on the what does the infrastructure look like for actually charging this particular machine. I don't have problem for my own charging my electric lawn and garden equipment at home, because I don't use it that often, and there's plenty of time for me to charge the batteries between the time that I use them. But when you look at, for example, a large building site, how are you managing that? I'll need to give a little shout out there to the previous presentation here from the gentleman from Volvo, who was talking about electrification strategy for a full work site. I'll give another example in that area. For example, the electric school bus industry. I think everyone agrees that school buses are ideal for electrification. They just run a fixed route per day. There's plenty of time for charging in between the routes, lots of things that are good. But the problem is that, but more often than not, all the school buses come back to a school parking lot or some other big parking lot to sit there during the empty time. And in that space, there is no infrastructure for the charging. And even if you start putting a few chargers in, if you have 50 buses that all need to be charged, that's going to be a big problem.
Right, good. And maybe I'll take one of the questions here in the chat and use it as an opportunity to turn a phrase. But could you kind of explain and take a minute or two to explain what you see as the true future of electrification? Right, where do you see it going in the coming years?
That's a very broad question. Someone was brave here. I could spend the rest of the afternoon to talk about that. I definitely think that Tesla started a revolution in the electric car space by providing performance and features that wasn't available in other vehicles. So it made it really desirable to go electric. It wasn't just a matter of saving money at the gas station. I think that we have started to see a trend where manufacturers of electric machinery are using that opportunity to provide functionality, for example, around automation or semi-automation that the electric machine lends itself for. So how to say, my crystal ball for the coming 5 years is that I think we will see a lot of innovation around how can I create additional value and desirability for the end user to be able to do things with the electric machines.
Okay, good answer. So the next question here is, well, you can maybe put your salesy hat back on. So it asks, you explained how important it is to have an optimization of the system. Does ZAPI Group have the possibility to support system integration?
Yes, we do. We do have that possibility both at various product companies, and if you go back and look at previous presentations here yesterday, I listened to a really nice presentation by Paolo Patroncini from 4E, which happens to be a dedicated system engineering company within the ZAPI Group. So depending on the level of system integration and the level of support that the customer needs, that is something that we really do on a daily basis.
Okay, the next question here is a bit more on the technical side. So how do you see the use of AC induction motors versus permanent magnet and other technologies trending in the off-highway space?
That's a good question. There's definitely a strong market push towards the brushless permanent magnet motors from an efficiency and size perspective. But I would personally say that I think that maybe customers again need to think a little bit more about what is the user requirements for this particular vehicle. Induction motors do have inherent advantages in controllability, in the ability to put a lot of current in, get high starting torque, do lots of field weakening, and have a wide speed range. They are very robust, and they are fairly economical to manufacture. You don't have the magnets and the labor of putting magnets into rotors and so on. So the trend is definitely that mostly everyone wants permanent magnet motors. I do think that there are applications where the induction motors still make a lot of sense.
Okay, Benny, thank you very much. That was the final question that came in via the chat. So once again, thank you for the great session, and thank you to the audience for being with us for the past 2 days. And with that, we will bid you farewell.
Thank you, everyone.